Alright, so let's try to do one more LeetCode problem tonight. That will put us at 5, which will make up for yesterday. We did one off camera, pretty easy one, on my tablet, which was a little tricky. The one I've chosen was remove element. Okay, ooh, lots and lots and lots of downvotes. Oh, given an integer array nums and an integer val, remove all occurrences of val in nums in place. The relative order of the elements may be changed. Since it is impossible to change the length of the array in some languages, you must instead have the result placed in the first part of the array nums. More formally, if there are k elements after removing the duplicates, then the first k elements of nums should hold the final result. It does not matter what you leave beyond the first k elements. Okay, very similar to the one I did earlier today. Return k after replacing the final result in the first k slots of name. Do not allocate extra space for another array. You must do this by modifying the input array in place with O1 extra memory. Okay, let's take a look at what our, let's make our whiteboard. Let's take a look at our constraints. Num's length is between 0 and 100. Num's I is 0 and 50, and value is between 0 and 100. Okay, the function we're calling, we don't need this list node anymore. Is the function remove element, taking a arguments of nums as type int array and value of type int and returning int. Oh, value is the number, is the value that we're removing. So for a test case, let's do let's do test array value or array equals int array of 1, 2, 3. Remove element A2 if remove element A2 is not equal to remove int array of Okay, Cool. There's our test case. There's the test. I don't know about equality. I don't know about equality of arrays in Kotlin, but we'll see. That'll be a to-do. Okay, let's see. Similar to our remove duplicates, we're going to have a left pointer and let's say we remove 2. The left pointer is going to contain the shifted elements. The right pointer is going to contain the pointer at which we're going to check. Hold on, let's think for a moment. Yeah, I think 2 pointers is the best way to do this. Is there anything else we could do? Hash it, maybe? No. Dex? No. Oh yeah, we have to do it in the constant place. Okay, well this is supposedly easy. A lot of downvotes for an easy question. I remember struggling mightily on the other one that's similar to this. Okay. So the first thing we need to do, things we need to do in this problem, we have to move R to the end of the array and take note when it travels beyond the array. We have to move L to record the good values. Doesn't need to travel to the end of the array to end. We have to swap we have to overwrite the value at left with R. And then if R is a good value, put it at L. If R is a bad value, skip it and go to the next good value. Let's do some more edge cases. Let's remove everything. Oh, our test cases are screwed up because we're returning an int. For now, let's just try removing the elements. Well, R is less than nums length. R plus plus. Oh, we didn't. Variable R equals 0. Variable L equals 0. And then we will return the first two elements. We'll return L plus 1 because here we're going from substring 0 to 1, or subarray 0 to 1. And it's actually asking for return k equals 2 with the first two elements of num being 2. This one returns k equals 5. So if we're at index, we can either do L plus 1 here, or we can do L plus 1 in the loop. Okay, so well, R is less than number's length. if nums r equals value, we have to deal with the case if the removed element is the first element. Do we do the Goldilocks case first? R++. Okay, so if R is 2, R moves 1. We could even do while nums r equals value. R++. And then if r equals nums length break well, nums r equals 2, r++. And here we'll say nums L equals nums R, then L++. That actually looks good, but I think there might be a problem. Okay, well, r is less than num's length. Well, num's r equals value. We scroll through. And if they all get removed, r is just gone. Or let's say, like, let's take a look at this case. Well, r equals value. R plus plus. Okay, so it doesn't equal value. So you skip that. Nums L equals nums R. That's okay. L plus plus R plus plus. Okay. So now, all numbers R equals value. R flies off the right. I break. Break outer. Humatic Kotlin. All right. Cool. Then we'll return 1, which is the index of L. So we take the first one. Let's try. So we tried 222. What if we try 221? Well, R is less than num's length. R plus plus. Numbers L equals numbers R. R goes out of bounds. R then becomes equal to num's length, and then we return 1. Perfect, so that case works. If num's length is 0, we just return 0, which takes the first 0 elements. So that case is good. What if all the elements are good? We skip that. Numbers L equals number R. L and R both go up. And the same thing happens again. Wait a minute. Well, R is less than num's length. R is at 2. Num's length is 3. So if that was 2, we break the outer, return 2, and we're good. But if they're both good, then this never runs. There's no change to the assignment. L and R both increment, and we return 3. So this actually looks like pretty good code. We tested the empty int array. We tested a... Are we going to test a single character? R is less than 1. R is not equal to val. We swap it with itself. We iterate off. We return 1. Okay, what if this is 2? R++. R flies off. We return 0. Cool, this looks like good code. My test case isn't good though. Hello, what happened? We freeze up? Okay, let's see the test case. If this break actually works. Oh, what? What? Did I not copy and paste it all? Dang, that's rough. Okay, let's try this. Num's length. Length is for strings. Already knew that. Okay. Let's do some more test cases. Oops. Empty test case. Test case with one bad variable. Test case with one good variable, and the rest bad variables. First one's bad. 2, 2, 3. I'm not going to be able to do this, by the way. I'm just doing this for LeetCode. Alright, we're going to submit this. Okay, it's a little slow, but we got it. Took half an hour. Okay, cool. Let's take a quick peek at the solution. 2 pointers. That's the only solution. Okay, yeah, pretty simple. Remove linked list elements, move zeros. Okay, cool. Alright. 5 LeetCode problems today. I'll take it. And we got pretty close to getting this on the first try. I just have to write down that array size, not length. Length is for strings. Okay, hopefully I'll remember. We do this enough times and I'll remember. Our break worked nicely. I'm gonna write this down. Outer at while break at outer. That worked like a charm. That was great. Alright, awesome. We got another LeetCode problem done. Cool, it's not even that late yet.